Okay, class 12 students, this is the second digital class for you. In the first class, we have discussed about the chapter solution, what is solution, type of solution, already we have discussed. So today we will discuss another topic which is called concentration of a solution. So before doing this, first time you should know what is concentration. Suppose this is a beaker, and in this beaker suppose some amount of water is present, and here you have added some amount of sugar, then it becomes a sugar solution. Now as the amount of sugar increases in this solution, the sweetness of the solution going on increasing, and that sweetness of the solution is said to be the concentration of the solution. I mean, as the sweetness of the solution increases, the concentration of the solution also increases. So what is concentration? Concentration means it is the amount of solute present in a given quantity of solution. As the amount of solute increases, the concentration of the solution also increases. As you know, there are two types of solutions. Some are called concentrated solution, some are called dilute solution. Concentrated solution means amount of solute may be high, or dilute solution means amount of solute is very less. Now suppose you have prepared a solution, suppose sugar solution, you have prepared some amount of sugar, you have dissolved in a given quantity of solution. Now if someone asks you what is the concentration of your solution, then how do you express it? How do you express the concentration of the solution? Actually, to express the concentration of the solution, there are different types of units you can use to express the concentration. So what type of units are used to express the concentration of a solution? So according to syllabus, some units are required like percentage, mole fraction, molarity, molality, normality, parts per million. That type of units are required, and by using that type of units you can express the concentration of a solution. So I'll explain one by one. First time I'll explain what is percentage strength. So number one unit, these are the unit of concentration, percentage. By using percentage you can express the concentration of a solution. For example, suppose you have prepared a solution and the solution is given 10% solution. What is the meaning of 10% solution? The meaning of this one is 10 gram of solute is present in 100 ml of solution. Suppose this is a solution, and in this solution, suppose the solution amount is 100 ml, and in this 100 ml solution 10 gram of solute is present. So 10% solution means 10 gram solute is present in 100 ml of solution. So if someone asks you what is the concentration of a solution, then you can express I have prepared a 10% solution. That means 10 gram solute is present in 100 ml solution. Similarly, suppose 20% solution. 20% solution means 20 gram of solute is present in 100 gram of or 100 ml of solution. Now, to express the percentage of a solution, there are three types of percentages. One is called m by m percent, one is called m by v percent, and one is called v by v percent. There are three types of percentage solution. M by m percent means mass by mass percent, m by v means mass by volume percent, v by v means volume by volume percent. Now what is the difference among them? Suppose it is given 10% m by m solution. M by m means mass by mass. I mean both the solute and the solution you have to express in terms of mass. 10% m by m means 10 gram solute is present in 100 gram of solution. Both you have to express in mass, 10 gram in 100 gram. So 10% m by m means 10 gram of solute is present in 100 gram of solution. Similarly, 10% m by v. What is the meaning of m by v? Mass by volume. So 10% m by v means 10 gram of solute is present in 100 ml of solution. I mean, solute you have to express in mass, and the solution you have to express in volume. That's why one express in gram, one express in volume, milliliter. So 10% m by v means 10 gram of solute is present in 100 ml of solution. And similarly, 10% v by v means 10% v by v means both you have to express in terms of volume. I mean 10 ml of solute is present in 100 ml of solution. Both you have to express in terms of volume. Suppose your solute is liquid, solvent is also liquid, then you have to express v by v. Suppose your solute is solid, solvent is liquid, then you have to express m by v. And if both solute and solvents are solid, then you have to express both in mass. So for example, this is sugar solution, as I have expressed. Suppose this is a sugar solution, sugar is solid, water is liquid, so you have to express in m by v. That means 10 gram of sugar is present in 100 ml of solution. So like this way you can express the concentration of a solution. Now how to prepare? For example, you want to prepare 10% m by v solution, mane you have to dissolve 10 gram of solute in 10 gram of solute should be present in 100 ml of solution. That means how much amount of solvent, I mean water, you have to take? 10 gram solute, but how much water you have to take? To do this in laboratory, you will get this type of volumetric flux. This type of volumetric flux you will get, and in the volumetric flux you will get a mark here. Up to this mark it contains 100 ml. This type of volumetric flux you will get. Different sizes volumetric flux you will get 100 ml, 500 ml, like this. So suppose this is a 100 ml flux. In this flux, if you want to prepare 10% m by v solution, then what you have to do? Suppose you want to prepare a sugar solution. First time you measure 10 gram of sugar, and that 10 gram of sugar you take in your volumetric flux. Suppose this is your 10 gram of sugar, and by taking this 10 gram of sugar, now you have to take the solvent. I mean you have to take water. You add little amount of water, then you shake the solution, you dissolve it. Now you increase the volume of water and you make it exactly up to the mark, that is means 100 ml. That means here 10 gram of solute, I mean 10 gram of sugar is present in 100 ml of solution. Solution means it contains both solute and solvent. So like this way you have to prepare the m by v solution. In case of m by m, v by v, no problem. 10 ml solute, 90 ml solution. In case of 10% m by m, 10 gram solute, 90 gram solvent. But in case of m by v, one is solid, one is liquid. That's why you have to use this type of volumetric flux. Otherwise you cannot determine the exact amount of water, how much amount of water you have to take. So this is the way to prepare the solution. And like this way you can prepare, you can express the concentration of a solution. To express the concentration of a solution, you can use the unit, and that unit is percentage. By using percentage you can express the concentration of a solution. I have prepared a solution 10% solution, I have prepared a solution 20% solution, I have prepared a solution 5% solution. Like this way different types of solution you can prepare. So this is one of the unit. Another unit, before going another unit, if a question asks like this, suppose 2 gram solute is dissolving 18 gram of solvent. Calculate the percentage strength. What is the percentage of the solution? To determine this, to determine the percentage of the solution, mass of solute how much? 2 gram. Mass of solution how much? Solution means both solute plus solvent. Solute 2 gram, solvent 18 gram. Total how much? 20. So 2 by 20 and you multiply it by 100. You will get 10%. So like this way you can determine the percentage of the solution. So this type of question may ask, suppose 2 gram solute is dissolved in 18 gram of solvent. What is the percentage of the solution? Then you can determine by using this formula. Mass of the solute divided by mass of solution, whole thing multiplied by 100, you will get the percentage. So this is about the percentage strength of a solution. Now we will move to another unit which is called mole fraction. By using mole fraction also, MOLE mole fraction, which is represented by a symbol chi, it is like x. This is called chi symbol. By using chi symbol, you can express the mole fraction of a solution. Now suppose this is a solution and the solution contains two substances, one is A, one is B. One is solute, one is solvent. Suppose A is solute, B is solvent, like that. If you want to determine the mole fraction of solute and solvent, the formula is mole fraction of solute is equal number of moles of solute divided by number of moles of solute plus number of moles of solvent. This is the formula to determine mole fraction. I mean, mole fraction of a substance is equal to the mole fraction of the substance divided by total number of moles of the substances present in the solution. Similarly, if you want to determine mole fraction of solvent chi B, then number of moles of solvent divided by number of moles of solute plus number of moles of solvent, total number of moles. And in case of mole fraction, the summation of the mole fraction, whether the solution contains 2 substances, 3 substances or 4 substances, the summation of the mole fraction is always unity. I mean, chi A plus chi B is equal always 1. Similarly, if a solution contains another substance C also, then chi A plus chi B plus chi C is also equal 1. I mean, the summation of mole fraction is always unity. So this is another unit. By using the mole fraction, you can express the concentration of a solution, and this is the formula to determine the mole fraction. You know number of moles. To determine number of moles, Na, how to determine? The given mass by molar mass. That is the formula to determine mole fraction. Suppose 10 gram of NaCl. How to determine number of moles? 10 gram divided by molar mass, 23 plus 35.58.5. Like this way you can determine the number of moles. So to determine number of moles, you do given mass divided by molar mass. Like this way you can determine number of moles, and if you get number of moles, then you can determine mole fraction also. So this is another unit to express the concentration of a solution. Okay, another unit will move to molarity, molality, normality. That unit we will do later on. So some numericals are given in your textbook to determine mole fraction, to determine percentage. You try to do that, and if you can't do, then you can ask me. Thank you for today.